of x equals 2 over x minus 3, and g of y equals 1 over y. First, we are asked to calculate f composed with g of y, which is f applied to g applied to y, which is also equal with f, and now we have to replace g of y with its algebraic expression, 1 over y. But f is 2 over x minus 3. So now, whenever we see x, we have to replace it with 1 over y. So I will copy down the 2, the fraction, and now instead of writing x, I will just write 1 over y and then minus 3. Now, the first thing we need to do is to simplify the denominator. To do that, we have to subtract two fractions. To subtract two fractions, we first need to bring them to the common denominator. In this case, one fraction has the denominator 1 and one has the denominator y. So the common denominator will be y. Then I have to write 2 over 1 over y minus, and so now instead of 3, I will write 3y over y, which is the same fraction as 3. Now, because I have a common denominator, I simply subtract the two numerators, 1 minus 3y, and I copy down the common denominator, which this is simply division of fractions. So using the division of fractions formula, we have 2 times y over 1 minus 3y, and that is our answer. F composed with g applied to y is 2 times y over 1 minus 3y. We are also asked to calculate the domain of this function. What is the domain? Of f composed with g? Well, let's think about this a little bit. We have the input y goes into the function g and outputs g of y. And this g of y will be the input to the next function, which is f, and out comes f of g of y. Okay, so first we need y to be in the domain of g. What is the domain of g? Well, because we divide by y, we have all the real numbers but 0. Okay? And now, second, we need that g of y to be in the domain of f. But what is the domain of f? Because I divide by x minus 3, x minus 3 cannot be 0. Then x cannot be 3. So the domain of x is all the points x that are different than 3. Okay, so g of y has to be different from 3. That means that 1 over y must be different from 3. And so that's the same thing as saying that y is different than 1 over 3. Thus, the domain of f composed with g will be all the numbers x with the property that x is different than 0 and x is different than 1 over 3. So remember, it doesn't really matter what name I use here for the variable for x. It can be x, it can be y, it can be anything. It's just a name that we use. It's a number x, real, but that is which number is different than 0 and different than 1 over 3.